All right, so for our final presentation of the day, Kyle Bank is here from Phoenix RealTime Solutions, and he's the Director of Business Development there and has been a big part of their growth in streaming. He's here to talk about some of the interesting work that they've done in trivia and gaming with WebRTC. So thank you very much, Kyle.
Thanks, Aaron. So here to talk today about some use cases for one-to-many streaming at scale. Using WebRTC, although the initial implementations of WebRTC, the purpose was to build multi-party chat applications. Phoenix is really focused on the one-to-many use cases with large audiences. And if we just look at what's happening in the space today for live streaming at scale, we look at major events all the time like the Super Bowl. And I'm going to play this clip here to show you kind of what we're seeing happening in the market today, not using WebRTC, but using HLS for delivery at scale over CDNs. So we regularly take these latency comparisons across the platforms that you can watch the content on. For the Super Bowl last year, these are a few of the platforms that it was available on. So you've got the feed in the stadium, Phoenix delivering with about 420 milliseconds or 0.42 seconds of latency, what we can do at scale, and then you kind of just wait for all the other applications. You could have been watching the stream on the CBS Sports mobile app, on cbssports.com, YouTube TV. These are 4 of, I believe, the 8 places you could have watched the content. And we're now 24 seconds past the play, and you haven't seen it happen on any of the platforms yet. So you can see this 28.2 seconds was an average across 100 users across the United States. So this isn't just one user's data. This is an average across 100 data points for each of these platforms. And this is really not abnormal. We see events all the time. We've measured Major League Baseball streams being 97, 98 seconds behind real time. And this is really the challenge and the problem that our company is out there to solve. And these are some of the headlines that we see in the media today talking about the challenges of live streaming today. Platforms crashing, high latency, not ideal user experiences. And we look at not just the latency and the delay of these platforms for live content, but also the variance of the user who has the best latency and the worst latency, or what we define as the audience drift. So on the CBS Sports app, you would have been 28.2 seconds behind real time, but the user with the worst latency was over 100 seconds. So the variance here is over a minute between multiple users in different parts of the country watching the same content. So we view drift as another measurement of the quality of service you're able to deliver to an audience with live content. And these are what those drift numbers were. So if you're watching on NFL.com, you could have been 95 seconds different from your neighbor watching the content. And what do these challenges in the live streaming industry do to the user experience? You've got long time to first frame, sometimes taking multiple seconds for a video to load, lack of audience synchronization like we just talked about, high latency, and oftentimes when you have a flash crowd joining an event, you end up having crashes and people not being able to watch at all. And what this does is it reduces the user acquisition, increases churn, and it prohibits certain interactive use cases that we really believe are the future of media. And so these are really the challenges out there today that we're addressing. And if you look at sports betting in particular, which is a space we're very active in, every second behind real time shortens the betting window. So betting companies in the UK, where betting's been legal for 50 or more years, are shutting the betting window 60 seconds or more before the event actually happens. And that 60 seconds is worth hundreds of millions of dollars in additional betting handle. It's a bit of a frustrating user experience, and it creates potential for fraud and arbitrage. So these are kind of the challenges posed specifically to the in-game sports betting industry. And when users are asked, would you be more likely to stream an event if it was synchronized with the broadcast, the answer is yes. On average, 60% of viewers worldwide would think that's a better user experience and more likely to stream, which really helps the entire industry and everyone move forward. So what are we focused on? And we've talked a bit about the problems and the challenges in the space for one-to-many. we're able to deliver content with WebRTC in less than a half a second of end-to-end latency. We can do this to large audiences. We've scaled in production to over 200,000 concurrent viewers and done tests at scale with 1 million plus concurrent viewers on a single channel. And we're able to synchronize within 100 milliseconds on the client side. So whether you're in a native mobile app or you're on the web, you're within a couple frames, 2 to 3 frames of the other viewers of the content. And alongside that, we're able to deliver data, whether that's sports betting data or triggering questions in a trivia app, that allows us to create these really interactive experiences around media. The benefits of real-time streaming, I mean, I think I'm preaching to the real-time crowd here, but we're able to increase the user acquisition, provide a higher level of engagement, and retain users. And really, ultimately, all of these things lead to driving additional monetization options, whether that's users watching for longer so we can drive additional ad revenue or drive additional subscription revenue because users are more likely to pay for a service that satisfies their needs in the streaming space. What can you do when you do enable real time in sports betting? And what you can do is you can make more bets available. So is Tiger going to make the next putt as you're watching the content in real time? And you're able to place that bet up until the event actually happens. And you also have a longer betting window. So the combination of more bets available, more time to bet, leads to more bets placed and higher revenues. And this is really what we're focused on in this space in particular to drive revenue for our customers that are delivering real-time media content. So how do we do this? How do we operate our platform today? We've built a global infrastructure based on a multi-cloud architecture, and we have 23 points of presence today, expanding to 30 by the end of this year, and this is across multiple cloud infrastructure providers. So we're providing an end-to-end platform as a service where our backbones are Google, Oracle, and other cloud infrastructures that enable us to have multiple points of failover if, for example, a certain company has a networking outage in a certain region of a certain country, or they have a load balancer issue, which we've seen across many of the major cloud platforms that take down Spotify, Snapchat, and basically the rest of the world for 30 minutes at a time every couple of years. So this is a map showing kind of where we are today and where we're expanding and growing to serve our customers' users. And the workflow that we've really built on is built on the standard of WebRTC. But different from the open source projects, we've rebuilt the entire stack from the UDP level up. So that's really every single line of code written from scratch, but we comply with the standard so that all the modern browsers that can decode a WebRTC stream can decode a Phoenix stream in real time. There's a number of different sources that we can take as ingest. We really prefer to take the raw media signal on an SDI or an HDMI cable into a Phoenix encoder that we can encode in real time and ingest up into our cloud. Alternatively, we have many customers that have a significant investment in encoders that can only output RTMP. And in that scenario, we can ingest the RTMP signal and repackage it as WebRTC, transcode it to multiple bit rates, and deliver that to the end users in real time. We're providing, as part of the workflow, our high availability real-time CDN, which is that network of today 23 points of presence, each of which is connected with private fiber that allow us to deliver the best quality that we can, and we don't have any losses on those long links. For example, if you have a user publishing a stream in LA, they're going to connect to our US Southwest data center, and if a viewer of that stream wants to view from Japan, they're going to automatically connect to the Tokyo data center, and those two data centers are connected with private fiber to minimize the packet loss and the jitter over those long links. At the edge, we can transform the stream for multiple bitrate adaptive delivery. That can actually happen at the contribution level for contributing from a browser or from our hardware-based encoder, or that can happen at the edge, where we create all of the layers available and can do the switching in real time on the client side based on the network quality, the jitter, and the other metrics we're collecting from the clients. We also are able to use our MPEG TS writer in order to create the chunked HLS and MPEG dash streams and make those available, whether it be for a fallback scenario or for recording for future VOD playback. And then on the egress side, we're delivering WebRTC to any WebRTC-capable browser or device. We have RTMP flash fallback, as we have a number of customers that are still serving users in Internet Explorer, IE7, and so we have to be able to support flash delivery for some of those use cases as well. And then on the viewer side, really all the modern browsers can decode a real-time stream from Phoenix as well as any other WebRTC provider. We also provide native SDKs for platforms like iOS, Android, and smart TV platforms. So this is really the workflow that we've built. And I think the key pieces are being able to deliver a high-quality 1080p 60 stream, do that at scale, and do that with ABR logic that can either run on-site or in the cloud that allow us to adapt to all the clients' network constraints in a similar way that HLS and Dash serve the live audiences today with adaptive bitrate. But this is just applying it to real time. So what are some of the other core focuses that we have? One is flash crowd elasticity. So how do we reach a really large audience when they all join the platform at the same time and we don't have knowledge of them actually, of when they're going to join, or we expect 50,000 users, but 250,000 users hit the platform all at once. So we built a lot of algorithms and technology on how to handle those types of situations and spin up servers in order to handle that type of load. Handle scale and channels and concurrent viewers. Some of our auction customers only have 50 to 100 viewers on a channel, but they might spin up 1,000 concurrent channels at the same time. So we have to be able to handle both the large audience, but also the large volume of channel use cases. We talked about multi-bitrate adaptive streaming. We also provide our customers with the analytics tools that enable them to really understand their user base, what usages are, but also the quality of service that we're able to deliver to them, and providing flexible ingest options. The ideal is to be able to contribute with a real-time protocol like WebRTC, but in other scenarios where someone has an IP camera and can only use RTSP as the ingest method, we want to still be able to serve those use cases. We talked a little bit about a multi-cloud architecture, and I think this is something unique to Phoenix, and what we've developed is this is deployed across multiple infrastructure providers so that when one of our customers, like a Cox Automotive, is running 1,000 channels at the same time, and Google may have a potential networking blip that may last 30 seconds or may last a minute, we want to be able to have seamless failover to continue to serve those users and those channels really without affecting the user experience in a massive way. Another unique thing that Phoenix is really after is how do we provide the highest level of service availability to our customers. And when you have a single encoder and a single point of ingest and a single infrastructure to deliver content, there's lots of points of failure, some of which are really out of your control. And so in order to minimize that, we built the ability for our customers to contribute 2 signals for a given channel. So high availability encoding from 2 separate pieces of hardware that ingest into 2 independent data centers that could be even on different parts of the world or different parts of the country. And we can send those streams over 2 completely independent network paths. They get to the same endpoint, and the subscriber is only viewing one of those streams. But if at any one point along that chain, whether it's the encoding, the ingest, or the delivery infrastructure has a problem, we're able to seamlessly fail over within a couple of frames to that backup stream. And that's really what, when you look at the workflow for CBS delivering the Super Bowl, this is the level of availability that companies, major broadcasters like that require. And so whether it be for auction content or trivia content or major sporting events, high availability is something we really want to be able to offer to our customers. I talked a little bit about load testing and how we prove to our customers the ability to scale. This is an example of a screenshot from one chart we did with a live customer where they wanted to see 250,000 viewers joining a stream all at once. We were able to create that scenario with virtual users in the cloud, all connecting to a single point of presence in Europe. This was for a sports betting use case where flash crowds are often common when you have a horse race and you have the race starts and everyone joins the stream at the same time. Very hard to predict what the load is going to be. And so as a result, we created this test environment for them and really proved out that we can handle 250,000+ concurrent viewers without the advance notice to spin up the servers. And this is done without an operations team in place. So this is all artificial intelligence algorithms that we've built on the back end to recognize load, look at current join rates, and predict future join rates, and spin up resources as quickly as possible in the cloud in order to handle that amount of egress. For ecosystem support, WebRTC is supported in all the modern browsers today, with the exception of Internet Explorer, which may not be defined as a modern browser, where we have to use Flash for fallback. We provide native SDKs for delivery to iOS, Android, Apple TV, and Android TV. Platforms that don't yet support decoding of real time include some of the smart TV platforms, which we are currently in the process of working directly with these manufacturers of hardware and software to implement real-time streaming within their environments. For encryption and DRM, all WebRTC by default is encrypted with AES 128-bit encryption end-to-end. And we're working with partners like Verimatrix on multi-write DRM. So DRM today exists in the world of HLS and Dash for Widevine, Fairplay, and PlayReady, which are the three major DRM platforms. But how does this get applied to a real-time WebRTC stream for a major broadcaster that's required in their contracts to provide DRM support and protection for their end users? Also, server-side ad insertion is a major challenge when you only have milliseconds to make ad decisions. How do you insert that into a real-time WebRTC stream? And that's something that we released in beta at IBC this year, working with partners for providing ads like Freewheel and DoubleClick. And this is something that's really critical to major broadcasters because that's one of their key monetization strategies is ad insertion. We believe our customers really see the future of interactive streaming. I'll walk through a couple of use cases that we've powered to date. The first of which was last year at the Oscars. We were selected by ABC to provide the second screen experience for in Oscars voting for who was wearing the red shoes walking down the red carpet, who's going to win the next award. And we worked with a partner to build the full end-to-end app solution that included real-time streaming during the commercial breaks of the Oscars, as well as the fan voting and engagement piece. We measured the stream on abc.com of the actual Oscars event at about 93 seconds behind the real-time stream that we were providing to the app. And real-time was really necessary because they wanted to enable the streaming during the commercial break, and they wanted it to start right when the commercial break started. So if we had a 20-second delay, by the time our stream started, that part of the event would have actually been over. And we, for this scenario, used our high availability encoding to two independent data centers over two independent network links, because that's the type of reliability that a company like ABC really requires in a solution like this. We work on many trivia apps and companies building experiences like HQ Trivia here in the US. One example of that is our partner Ex Machina Group that's based in the Netherlands. We worked with them to build this app Q12, which at its peak was serving 200,000 plus concurrent users on iOS and Android, and these users are all joining over the course of a couple of minutes. And it was about a 15-minute event that runs every day. The app is still live. And they're a great partner of ours. And we're enabling these low latency synchronous experiences that previously were just available by delivering Flash and RTMP. And so we view ourselves really as one of the replacement options for that. Another unique use case was Your Call Football. This was a new innovative football league where the fans actually called the plays themselves. So before every offensive down, they pushed out 3 options. The fans voted on whether they wanted to do a run or a pass, or whatever play that they desired, and they actually ran that play next on the field. And the only way to deliver a user experience like this is to deliver real-time streaming and do that at scale when they have thousands of concurrent users. We also partnered with Barstool Sports for this experience and did overlays of audio commentary from some folks from the Barstool team. So we're really out there enabling users and companies to build interactive experiences, whether it be fan voting, play calling, audio overlays. And so these are really new experiences that WebRTC and real-time at scale enables. We actually worked with an eSports tournament in Saudi Arabia last year where they wanted to deliver a real-time experience with Twitter integration. So if people are tweeting about the event in real time and the stream's being delivered 20 seconds later, there was really a mismatch in interactivity. So we delivered that as part of a project in Saudi Arabia. Cox Automotive is an interesting use case. We power over $50 billion of annual automobile sales with them. They run 1,000 live channels with us every day. There's about 50 to 100 viewers per channel, but the overall audience size and scale required for the number of channels is pretty immense. So they're, I think, one of the key use cases that WebRTC in real time enables. Just to conclude, we believe that the time for real time is now. I think that's why we're all at this conference about WebRTC. Enabling new use cases that are really changing the way that media is delivered and companies interact with real-time content. So I'll pause there and can open it up to any questions about some of the things we've been working on.
Any questions for Kyle? I'll say I think it's, we've had a lot of really interesting technical conversations today. I really enjoy hearing this as well and thinking about things like the Your Call application there, because it helps us to think about how we can really take all of these technical advances that we're working on in the standards and apply them not to just delivering things with lower latency, but creating something that's an entirely different experience than is possible with current technology. And so I think it's great for us as technologists to keep that in mind. So we have a question here for Kyle.
Man, I was at the wrong event. I should have been here. I'd like to know, did you have a two-way push technology for both sides, and the latency, was it there to actually do a real-time interplay? Is that available right now?
Sure, yeah. So we work with customers that have both the one-to-many use cases, but also some that are one-to-one and some that are multi-party chat. So we provide APIs to our customers that are really flexible, that enable them to build these types of experiences. We call the one-to-many our channel API, because you think of it as a TV channel, and the multi-party chat use case we call the room API. So you're publishing, multiple people publishing into a room, and viewers are subscribing to that room itself. And one kind of example that I didn't touch on before, the Winter Olympics in 2018 in South Korea, we enabled a use case where they wanted to deliver one-to-one video chat, but do that at 1080p quality and 3 megabits per second. And so we were able to deliver that type of experience in a one-to-one scenario where many of the other providers or companies working in WebRTC, there's challenges in delivering that type of quality in a real-time environment. So the short answer is yeah, we're working on those types of use cases as well.
So your bit rate can adjust based on the performance down the other end? So it's automatically adjusted?
Yeah, exactly. So we have multi-bit rate transcoding that can either run on-premise or can run in the cloud, that allows us to take in the 1080p 60 signal and create all the quality layers below that, the 720p, 480p, et cetera, all the way down the bitrate ladder. And we go all the way down to, I think, like 92 kbps as our lowest layer. And then we go to audio-only mode.
You mentioned end-to-end encryption. You support end-to-end encryption?
Yeah, so we support the AES 128-bit encryption. What we're working on is enabling multi-rights DRM, the standard DRM capabilities.
DRM is content protection. That's not encryption. But you're transcoding in the middle. How do you transcode if your payload is encrypted? You just said you transcode, right?
Yeah, we do transcoding.
So if you do not have access to the content because it's encrypted, how do you transcode?
That's a really good question, and I don't know if I have quite the technical answer that you're looking for, but certainly happy to follow up and discuss that.
Thank you.
Sure.
Any other questions? All right, so that concludes today. First, thank you to Kyle.